So hello, this video is on derivatives of inverse trig functions. In the past, we did derivatives of inverses in general. Remember what you know about inverses? We talked about three things. One, the x and y's are flipped. Two, we talked about how on a graph, they're mirror images of each other. And three, we talked about how their slopes are reciprocals of each other. So if one slope was 3/4, its inverse slope would be 4/3. But now how is it different from trig functions? And I know how much you guys love trig functions. It's being sarcastic. But let's talk about how to take them and how to do. And it's actually, the process is not that, it's actually a little bit easier than the last step that we learned. So first of all, as a bit of a what's the word I'm looking for? It's a bit of a notation note. What you need to know is that arc sine or arc something means the same thing as inverse. So this right here, this little term right here, sine of arc sine or arc sine of sine equals x. Again, that's a fancy way of saying they're inverses of each other. Sine and arc sine. Like if I put an inverse instead of another function, you should get x. And here you see pictures of what arc sine, arc tan, arc cosecant. Again, they all mean sine inverse, tan inverse, or whatever. You don't need to know the graphs. I've never memorized these graphs. They're just there for your reference. But one of the things that you're expected to do, and I told you it's coming back to you the whole semester, the whole year, is how to do these trig functions without a calculator. And again, we're going to use the unit circle. In case you forgot the unit circle, I draw a set of axes. I draw a circle. I have 1, 2, 3 points here. And I go 1, 2, 3, 1, 2, 3, all over 2. Sorry for my sloppy writing. And then I square root all the numerators. And then the one thing that you probably forgot is, like, what are these measures? Well, this first measure, if I zoom in, this is pi over 6. This is pi over 4. This is pi over 3. And this 90 degree is pi over 2. And the last thing I told you guys need to know are the four main points. Like this one is 1, 0. This one's 0, 1. This one's -1, 0. This is 0, -1. And another thing I also taught you is that the x-coordinate is cosine and the y-coordinate is sine. Okay, that's everything about the unit circle. And again, it's not that much difficult. I know you guys don't like memorizing it. I know you guys like writing it, but it's not. We're not asking too much. So there's a lot of things that they're asking you for. I'm just going to ask for two things, or I'm just going to go over two of the exercises with you. First question: arc cosine -1. So again, arc cosine or cosine to -1 means the inverse of cosine. So you're saying, what does it mean, the inverse of cosine? So in the past, I said, hey, what's the cosine of pi over 3, for example, right? And then you gave me a value. In this case, if I look at my graph, the cosine of pi over 3, I go to pi over 3, I look at my coordinates, and the x-coordinate is 1/2. So that was pretty easy. But now they're saying, find me arc cosine of -1. So what that means is, whose radian measure, whose, has to be with like a pi, some sort of value there, who has a value, who has an x-coordinate of -1. So if I look at my graph, again, I'm looking at all my x-coordinates, and I see here one of my x-coordinates is -1 here. This, in case you forgot, all the way halfway through the unit circle is pi. So arc cosine of -1 is pi. Again, you gotta practice how to do this without a calculator. And the second one I'm going to do for you today is this one, arc sine of -3/2. So I guess what I'm looking for here, again, is now the y-coordinate is (3/2). Well, I know that (3/2) with the y-coordinate is up here, pi over 3, but this isn't negative. So, long story short, I'm trying to find where would this y-coordinate be negative. Well, just to give you a quick review, this point right here, which is kind of like mirror images of this point over here, would be the exact same coordinate, but with a negative x-coordinate, because it's on the other side. It's on the other side of the x-axis. This mirror image, if I go, if I mirror this back down here, like so, see how this is a mirror image of this, would have the same coordinates, except for now both coordinates are negative. So for the most part, these questions they usually give you a domain and a range. Like there's infinite answers, but they usually give you, so usually it's from 0 to 2 pi. So I already have my first answer. And then the second answer, again, I'm going to do a mirror image again. If I go across here, these are going to be mirror points on a circle. This will have the same coordinates, except for, I know it's getting a little bit messy here. Let me do a different color. Except for x is going to be positive this time, but my y coordinate is now negative because it's on the bottom of the x-axis. So I'm saying, where's arcsine? I found it. It's here. Or where's arcsine of negative radical 3 over 2? It's here and here. Where you may have forgotten is what radian measures that. If you forgot, remember I can just go around the circle. This is pi over 6. This is technically 2 pi over 6. Okay. And then this is 3 pi over 6. This is 4 pi over 6. This will be 5 pi over 6 that I didn't draw. And this is 6 pi over 6. Over here will be 7 pi over 6. And this one right here is going to be 8 pi over 6. 8 pi over 6 reduces, so that answer is going to be 4 pi over 3. Then, this is going to be 9 pi over 6, and this one's going to be 10 pi over 6. And 10 pi over 6 also reduces, so my two values are 5 pi over 3 and 4 pi over 3. So, that's how you find arc sine, arc cosine without a calculator, using your unit circle. Now, if you go to the next page, here are the formulas you need to know. So the only most difficult part about this section is that you need to memorize these functions. You may notice that there is a pattern. The derivative of arc sine, the derivative of sine inverse, is 1 over radical 1 minus x squared. The derivative of cosine is the exact same thing, except for there's a minus here. So if you look at these two closely, it's the same thing, except for there's a minus. If I look at tangent and cotangent, tangent is 1 over 1 plus x squared. Cotangent has a negative. Secant is 1 over the absolute value x, square root of x squared minus 1. Cosecant, same thing, except for it has a minus right here. So let's try a couple of these examples. Here on the bottom, it says find the derivative of sine inverse 3x. Okay, so if you remember, this problem, or there's no sine to the negative 1 formula, but arc sine and sine to the negative 1 mean the same thing. Here's how you find the derivative. All you do is take 3x and put it everywhere you see x in the problem. Then, because it's derivative, I have to multiply by the derivative of the inside. Or, if the inside here is 3x, I just multiply by 3. So my answer, first of all, I will write the formula. This is the formula for the derivative of sine inverse. But since I want sine inverse of 3x, instead I'm going to put a 3x everywhere I see x, and then multiply by the derivative, which in this case is 3. To simplify it, I have a 3 on top. On the bottom, I have square root of 1 minus 9x squared. So that's all you have to do. The process is actually very, very simple compared to things that we've done in the past. Since I'm running out of space, I'll continue over here. Okay, ln 1 plus x squared plus arc cotangent x. So the first one is very simple, ln. We did that last chapter. 1 over 1 plus x squared times 2x. Right? Because the derivative of ln is 1 over x, and then I multiply by the derivative inside. Let me just put that in a bracket for now. Plus, it just says arc cotangent x. So all I have to do is go to my formula and just copy literally arc cotangent x, which is negative 1 over 1 plus x squared. You could simplify this by putting the 2x up on top, but for sake of time, you could stop there. And the last one, again, I'm running out of space, so let me erase this over here. The last one says, I want the derivative of arc secant x to the third. So all I do is I'm going to look at my arc secant formula, plug in x to the third everywhere I see x, and then multiply by the derivative of x to the third. So in this case, I'm going to write arc secant x to the third. Its derivative is going to be 1 over absolute value x to the third square root of x to the third squared minus 1. So all I did was put in x third everywhere I saw x, multiplying by the derivative of x to the third, which is 3x squared. Again, you could simplify this. I could put this 3x squared up in the top. I can make this x to the 6, but that's really the answer. So hopefully you guys don't find this too difficult. And the last example I want to go over for you, something we keep practicing over and over again, you'll see on the AP exam, is lines tangent to the function. So if it says find the tangent line, find the line tangent, I always start with y minus y1 equals m parentheses x minus x1, point slope form. First thing they give me is x equals -1. So I'm going to write x a minus minus 1, which is x plus 1. Then, remember, to get to get y, right here, I'll take -1, plug it in here, and solve for y. -1 squared tangent inverse of -1. Okay. Well, -1 squared is 1. That's easy. Now, here we go again. If you really want to, you could use a calculator. But again, you need to practice without it. I need a tangent inverse of -1. Or basically, whose tangent is -1? Which radian measure gives me a tangent -1? Tangent, in case you forgot, is sine over cosine. So basically, on the unit circle, who has the same sine and same cosine, or who has the same x-coordinate and y-coordinate? And I'm not going to go through the details, but tangent, like for example, it happens at pi over 4 when I have radical 2 over 2. And that continues on all 4 parts of the unit circle. Like this will be radical 2 over 2, radical 2 over 2, radical 2 over 2. But depending on where you are, you're going to have some negatives. At this coordinate over here, I'm going to have my x-coordinate be negative. And on the bottom right, same thing except for only the y-coordinate is negative. So these two places here and here are where tangent is -1. So for the sake of this tangent line, I'm just going to use 1. This is pi over 4. This is 2 pi over 4. And this line right here is 3 pi over 4. So my answer for y is 3 pi over 4. So I am one step closer to solving this problem. I only have one step left, which is m. So let me erase this real quick. And let's solve for m. To solve for m, remember you take the derivative and plug in your x. F prime x, you may notice this is a product rule. I've got one thing multiplied by another thing. So this will be 2x, leave the second one alone, plus leave the first one alone, and the derivative of the second one, the derivative of tangent inverse, if you look at your paper, is 1 over 1 plus x squared. So now all I'm going to do is plug in -1 and see what I get. If I plug in -1 into the second term, just to save you time, if I plug in -1 here, this becomes 1 over 2, and this becomes 1, so this just becomes 1/2. On this one, if I plug in a -1 here, this becomes -2. And again, here we go again, tangent inverse of -1. Whose tangent is -1? We just did this, so whose tangent is -1? Well, this one and this one. For equations of lines, I just need to use one of them. This one has a tangent of -1. This one, if you remember, is 3 pi over 4. So I could simplify this, again, for sake of time for this video, we'll just stop it there. But to make a long story short, this is -6 pi over 4 plus 2 over 4. You can get 2 minus 6 pi over 4. And again, you can just stop wherever you're at. So hopefully you understand derivatives of inverses. There's basically 3 pieces we went over: how to do it without a calculator, how to do it without a calculator, remembering the unit circle, using that table, memorizing this table to find the derivatives of different inverse functions, and lastly, doing it to find equations of lines that are tangent to the function. So if you have any questions, let me know, put it in the quiz, and then you can also ask me in class. We'll go over, I know you guys want to go over in class, so we'll also go over it there as well. So thank you for watching, and I'll see y'all later.